Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 8.2 entitled Zero and Negative Exponents. And what we're going to do today is we're going to evaluate powers that have an exponent of 0 or an exponent that's a negative number. And we're still going to use the product of powers property to help simplify our expressions. But we want to make sure that when we rewrite all of our exponential expressions that they end up having positive exponents. So before we get going on actual examples, I want to just kind of go over a conceptual thought process with you, okay? And if you have a calculator, you can do this on your calculator. But we're going to complete the following tables for each of these expressions. Okay, so here I have values for x from 3 to negative 3, and my equation here is y equals 2 to the x, and I want to solve for y. So I'm basically going to substitute in these numbers for x. So I'll have 2 to the third power. So that's 2 times 2 times 2, which is 8. And then if I have 2 to the fourth power, oops, sorry, jumping ahead. 2 to the second power, I get 4. 3 times 2 is 4. And 2 to the first is going to be 2. So as you look at these y values in this column here, you can see that we're dividing by 2 every single time. So if I kept dividing by 2, my next number should be a 1. And then 1 divided by 2 is a half. And then a half divided by 2 is a fourth. And a fourth divided by 2 is an eighth. So that's the numbers that we're going to get when we finish this column here where we're substituting. 2 to the 0 power. If you do that on your calculator, you'll get an answer of 1. That's kind of like taking 2 and dividing it by itself. And then 2 to the negative 1 power. Anytime you have a negative exponent, that kind of tells you that you're going to be doing the inverse. And we'll talk more about that process as we get through the rest of the notes. Okay, but if you do this on your calculator, it will give you 1/2. 2 to the negative 2, if you do that on your calculator, you'll get 1/4. 2 to the negative third, if you type that in, you'll get 1/8. And notice here that these are reciprocals of each other. Okay, so that's going to happen every time that we deal with negative exponents. If I have 2 to the third, or 2 to the negative third, and I know what 2 to the third is, then I just do 1 over that number. Okay, so let's try it again here for our 3. So we'll have 3 to the third power, that's 27. Oops, 3 squared is 9. 3 to the first power is 3. So again, we're dividing by 3. If I kept dividing by 3, I would get 1 and 1/3. 1/3 divided by 3 is a 9th. A 9th divided by a third is 1 over 27. And again, that's because 3 to the 0 power is like taking 3 and dividing it by itself, so you get 1. 3 to the negative 1, that's like doing 3 to the first power, which is 3, and then doing 1 over that. 3 to the negative 2, that's like doing 3 squared, and then doing 1 over that number, which is 9. 3 to the negative 3, it's like doing 3 to the third, which is 27, but then writing it as 1 over that number. And again, these are reciprocals of each other. The positive and the negative values are going to get you a reciprocal. So that's the observation we need to make with those tables and that little activity. So there are a couple different rules here that we noticed as we were going through that chart. Anytime we have a number that's raised to a power of 0, that's always going to equal 1. It's kind of like taking that number and dividing it by itself. And then when we have a negative exponent, let's just say negative a, that's the same thing as doing 1 over n to the a power. And it works the other way as well. We're going to see that as we go through the rest of our notes. If we had that negative exponent in the denominator, then it would be like taking n to the positive a over 1. So basically, negative exponents are bad. We don't want them in our expressions. And if they're negative in the numerator, we're going to move them down to the denominator to make them positive. If they're negative in the denominator, we're going to move them up to the numerator to make them positive. So that's how we'll deal with simplifying our negative exponents. Okay, so those were hopefully two of the observations that you noticed as we were completing those charts. Now, those are the rules that we're going to practice and use in this section of notes. And for example 1 here, I just want to re-emphasize that anything to a power of 0 is 1. So 8 to the 0 power is 1. It's like 8 divided by 8. Pi to the 0 power. If you have a pi key on your calculator, do pi to the 0 power, you'll get 1. It's like pi divided by pi. Even if it's a decimal, 5.2 to the 0 power, you're going to get 1. It's like 5.2 divided by 5.2. Negative a half, even if it's a negative number or a fraction, anything that you raise to a power of 0 is 1. Okay? However, when you have 0 to a 0 power, that's like taking the number and dividing it by itself. You can't divide by 0. So that one is going to be undefined. So that's really the only exception if you had 0 to the 0 power. You don't see that very often though. But that might be, a good extra credit question or something like that, because that's a higher level of thinking, because you really have to understand what it means to be raised to the power of 0. So that was just to emphasize that when you see that anything to a power of 0 is 1, sometimes students think that it's, 8 to the 0 power is 1, so it's 8 to the first power, so then the answer is 8, and that's not correct thinking, okay? Anything to a power of 0 is 1. Okay, now here we're going to move some of these little pieces around now when we're evaluating these expressions, okay? So I have these little red boxes for a reason, and I have these negative exponents in red for a reason as well, okay? Because when we're dealing with these types of expressions, we want to try to get rid of the negative exponents if at all possible. So for right now, both of these expressions are in the numerator. Okay, there's no fractions or anything like that. Now, what we're going to do is we're going to rewrite it so that the positive exponents stay where they are, and the next negative exponents are going to either move from the numerator to the denominator or the denominator to the numerator. So since both of these expressions are in the numerator, this x to the 8th, if we rewrote it, it would stay in the numerator. But this x to the negative 5th, it would move down to the denominator. And notice what happens when I move it to the denominator. That negative goes away. So I'll rewrite the problem here so that you can still see what the original problem was. This was x to the 8th and x to the negative 5th. So I move this negative 5th down here to my denominator then. Okay, so now I have x to the 8th over x to the 5th, which is really 8 x's on the top and 5 x's on the bottom. So you know this, when we're dealing with fractions, when we're reducing, we can cancel out stuff that's the same. So I've got 1, 2, 3, 4, 5 x's that I can cancel from top and bottom, which leaves me with 3 left over in the numerator. So you can write it x to the third or x to the third over 1 if you'd like. Now the trick here is that when you have two bases that you are dividing, you subtract the exponents. Okay? And that's a property that we're going to talk more about in the future explicitly. Okay? But when you are dividing the bases, you subtract the exponents. That's the rule that we're going to be practicing here. Okay, now for part B, again, these are both in the numerator right now. We have 7 squared and 7 to the negative fourth. So this 7 squared, he would stay in the numerator. But this 7 to the negative 4, he would move down to the denominator because he's negative. Okay, so if he's negative in the numerator, you're going to move him to the opposite location. So that means that that negative exponent goes away then. That's why I'm moving just him down to the denominator. See that little red negative? He's gone now. Gone. So we have 7 squared over 7 to the fourth. Now, I'm going to write this out again like I did before. This is 7 times 7 over 7 times 7 times 7 times 7. And again, I'm going to cancel. Now, this problem's a little bit different than what we did above because everything cancels from the top. So that means I have a 1 left over in the top, and I have 7 times 7 left over in the bottom, which is 49. Or you could think of it as 1 over 7 squared. Now, we're still using this rule here that when you are dividing the bases, you subtract the exponents. We're still doing that. My bases are the same. They're both 7s. And I can take 2 minus 4, but I get a negative 2. So 7 to the negative 2 means that I'd have to do 7 squared and then do 1 over whatever 7 squared is. And 7 squared is 49. So using that rule for subtraction still works here. And I like to refer to this type of a problem where you have more on the bottom, you have a bigger degree or a bigger exponent in the bottom. I like to call that bottom heavy. So basically you can just subtract 4 minus 2 and you know that you have 2 left over. And since it's in the bottom where more of them were, you know those 2 leftover ones are going to stay in the bottom of your fraction. And for part A, we had more in the top, so I like to call that top heavy. So you can still subtract 8 and 5 and know that you're going to have 3 left over, but those 3 are going to be left over in the top because it's top heavy. You had more in the top to begin with. So your answer will have more of those terms, that exponent in the numerator. Okay, let's try part C and D. Okay, now for part C, I have y to the 8th in my numerator and y to the negative 6 in my denominator. Now the only part here that's negative is this y to the negative 6. So he is going to get moved from the denominator up to my numerator. And when I do that, when I move him up, notice that that negative exponent goes away. Now the y to the 8th, he's just going to stay in the top. He's still in the top. So nothing really happens to him. And there's nothing in my denominator either now. So let me rewrite my original equation here. I had y to the 8th and then y to the negative 6th. So I'm still keeping that y to the 8th in the numerator, and now I have this y to the negative 6 that's moved up. Okay, and he's become positive when he moved up. So now there's nothing left over in the denominator. It's just a 1. So I'll have y to the 6th 6th times y to the 8th over 1. And this is the property that we talked about yesterday. When you have the bases that you're multiplying, you add your exponents. So that's just going to be y to the 14th. And if you want to put it over 1, you can. Or if you just want to leave it y to the 14th, you can do that too. Okay, now part D, I've kind of taken away the little red boxes. Okay, taken away the training wheels here. This big expression, there's a couple different ways that we could think of this. Okay, one way is you could think of this as all being over a 1. And you could think of it as this negative 1 here, this outside exponent, is being applied to this whole expression in the brackets. So that means that whole expression has a negative exponent. So I need to move it from the numerator down to the denominator. So I'll have negative 9 squared to the first. And then I don't have anything left over in my numerator, so I just put a 1 there for a placeholder. And now I have a power to a power that I can multiply. So now I'll have negative 9 squared, and negative 9 times negative 9 is going to be 81. So that's one way to think through that problem. The other way to think through that problem, let me rewrite it from the beginning, is to recognize that you have a power to a power. So you could multiply here, first thing, and then you would get negative 9 to the negative 2. Now this is still in the numerator, so I'm still going to have to move this negative exponent, this term with the negative exponent, down to my denominator so that he becomes positive. And now I don't have anything in my numerator, so I'll just put the 1 there for a placeholder. And now I'm at the same spot that I was before. So negative 9 times negative 9 is 81, so I get 1 over 81. So basically all we're doing here from this first way to do it to the second way to do it is we're flip-flopping these first two steps. Either you move it and then distribute, or you distribute and then you move the exponent. Either way, it works out to be the same. So again, you need to pick a method that you prefer and use it. Okay, so example 3 has 4 parts to it, A, B, C, and D. And I brought back the little red boxes again because only parts of these expressions are going to get moved. Okay, and for part A here, we have 5 times A to the negative 3. And this is all over 1. So if you want to think of it that way as being all over 1, you can. And again, I'm only going to move the part that has a negative exponent. So the part that has the negative exponent is just the A to the negative 3. Just that part right there. So that's what's going to get moved down to my denominator. So I'm going to take that A to the negative 3 and I'm going to move him, whoa, down to the denominator. Whoops, that didn't work so smooth there. Something happened with the imaging there. Okay, so let's just rewrite it this way. Oops. Okay, so let's leave let's use black. Is that the black? Okay, so the A to the negative 3 will move down to the denominator now, but now it's a positive 3. That negative goes away. And this 5 is just going to stay here in the numerator. So now I have 5 over A to the 3rd. I can't do anything to the 5, and I can't do anything to the A to the 3rd. So that's my answer. All I had to do for that one was to move the negative exponent so that I have an expression that has all positive exponents. Okay, so let's take a look at part B now. Part B has x to the negative 12th times y to the negative 6 or positive 16th. So again, the only thing that has a negative exponent is this x to the negative 12. So that's the only part of the problem that we have an issue with. And again, this is all over 1 right now. This is all in the numerator. So to make him a positive 12, I'm going to move him down to the denominator. Let's see if I'll be able to move this guy. Have the imaging work on that one. Nope. Okay, something's wrong on the imaging with that one too. So again, I'll just rewrite it. So my x to the negative 12th moves down to the denominator, but once I move it down, kind of like when you move it across that little fraction bar, that little negative gets scraped away and he becomes a positive 12. And this y to the 16th, he's already positive, so I'm just going to leave him y to the 16th. Okay, so then I have y to the 16th over x to the 12th. Now, I know I said before that when you have fractions with exponents, you can subtract them. That's only if my bases are the same. Here my bases aren't the same, so I can't subtract the 16 and the 12. So I'm done. Okay, so the main part of these problems is to recognize what's negative and what's positive, what gets moved and what stays. Okay, now part C, I'm guessing that this little guy is going to have an issue when he gets moved too. Yep. Okay, so I'll just continue writing. Okay, part C now, I have 9 and b squared and then a to the negative 7. Okay, so this a to the negative 7, that's what I have an issue with. He's not supposed to be negative. We don't want negative exponents. He's bad. So we want to change him. So we're going to move him up to the numerator. And when I do that, he'll become positive. So I'll have a to the positive 7 in my numerator now. And I still have the 9 in the numerator. He's okay. He's still had a positive exponent. And the b squared was in the numerator. He's okay. He can stay in the numerator. He was a positive exponent. And then after I move this a to the negative 7 up, I don't have anything left over in my denominator. So I'm just going to put a 1 there for placeholder. Now you can leave your answer like that if you want, but we like to write the numbers first, and then we like to put the variables in descending order. And if you want to put it over 1, that's totally fine. But again, that's all I can do to simplify this expression because I don't know what the a and the b are. I can't add the 7 and the 9 because a and b are not the same. They have different variables, different bases. If it was a to the 7th and a to the 2nd, then I could add them. But since it's an a and b and they're different, I can't combine them. Okay, last one then for part D. This whole expression is over 1. And this 3 and the c are both being raised to a power of negative 2. So this whole expression is going to have to move because I don't want that exponent to be negative. I want it to be positive. So if he's negative in the numerator, then I got to move him down to the denominator. So I'll have 3c to the positive 2. Then I won't have anything in my numerator, so that's where I'll put the 1 for a placeholder. Now again, there's a couple different ways you can think of this. You can think of this as 3c times 3c, or you could think of it as distributing. I'll do that in blue. You could think of the 3c squared as getting distributed. But either way, you're going to end up with 3 times 3, which is 9, and c times c, which is c squared. So you get 1 over 9c squared. And even if you distribute, you'd still have 1 over 3 squared times c squared. And then that 3 squared is 9. And then you leave the c squared. So either way you want to think about how to simplify that expression, you're going to get the same correct answer. So this type of problem here, where there's, from this step on, there's 2 different ways to simplify it. This is what makes all of this exponent stuff a little tricky because some people prefer to do it this way, some people prefer to do it this way, and sometimes you get confused when you see it one way but you like to do it another. So pick a method that works for you and makes sense for you and stick with it. So the main thing you want to practice for today is making sure that you know what part of the term has a negative exponent, if it's just a little part of it or if it's the whole thing in parentheses, and make sure that you're moving that either from numerator to denominator or from denominator to numerator so that it becomes a positive exponent. We want positive exponents. They're good. We don't want any negative exponents. So definitely practice this homework assignment. And if you have any questions, come on in and see me before school.